so inspiring, all these creative ideas. So next we have Lita Nelson. So Lita was the director of the Technology Licensing Office here at MIT until this past spring. The TLO manages over 350 new inventions per year. You can correct me if it's up since then. Yeah. You'll be able to tell me how many of everything, but Lita earned her Bachelor's of Science and Master's degrees in Chemical Engineering from MIT, and she has an MS in Management from MIT as a Sloan Fellow. Prior to joining the MIT Technology Licensing Office, Lita spent 20 years in industry, primarily in the fields of membrane separations, medical devices, and biotechnology. She's widely published in the field of technology transfer in university and industry collaborations. What I had asked Lita to speak about today is IP for open innovation. So here you go, Lita.
Well, you've all been told by Bill Aulette that ideas ain't worth anything. So let me explain why you might be interested in intellectual property, which is basically there to protect ideas. If you think, not everybody understands this, but if you think in terms of the type of intellectual property that we're talking about, we're mostly in technology licensing and the like, it's patents and a little bit on copyright of software. So what does a patent do? Most people don't realize that a patent doesn't allow you to do anything except exclude other people from practicing your invention. You can have a patent, but you might not be able, for example, if you had a patent on a rocker for a chair, but somebody else had a patent on chairs of all types. Well, you couldn't make a rocking chair because the other guy could exclude you from making chairs. So why would you be interested in a place like open innovation in protecting an invention from being used by others? And this gets asked a lot. The reason is to go from an idea to something that is on the market as an innovation, and Bill's shown you the path. Depending on what the technology is, you might be able to bootstrap it and just grow by selling your stuff off, and then you grow bigger, and then maybe make another one. But if the idea is instead a radical finding from research, the chances are to get it into being a product will be a very high-risk, I'll call it opportunity, but high-risk requirement. If you've got an understanding of a new pathway in biotechnology, and you've identified a class of compounds that hit that pathway, well, it's going to take millions, if not tens of millions, if not hundreds of millions in some cases, to get to phase 3 clinical trials. And at that point, statistically, you have a 50% chance of failure. Earlier in that stream, you probably have a 95% chance of failure when the first investment comes in. So if after you show the way to do it, the next guy can come in within a year instead of the decade it took you, who's going to invest the money in the first $300 million? And that is how what we talk about at MIT when we talk about protecting your invention with intellectual property so that somebody will invest in that invention enough to take the risk of bringing it to market, because when it hits the market, you have some limited time of protection from competitors coming in. It's the whole equation of why a university that publishes and wants their ideas to get out into the world would be involved in the idea of intellectual property. Now, people are always giving examples of inventions that didn't need it. And all I can say is software is from Mars and biotech is from Venus. And when people start asking, is intellectual property important in the bringing out of the results of research? And they're talking software here and biotech there. You do not have an intelligent conversation. You just have an argument. So that's why the technology licensing does what it does. Now, not all of you probably understand what the rules are on who owns the intellectual property, and it's probably useful to know that. Fundamentally, if you're a student and you're in a class, or you're in your dorm or wherever, and you make an intellectual invention, it's yours. However, if you're a student in a research lab, now you're under the rules that the professor would have, who also would have own the invention if it was done outside MIT. But if it's done under a grant, or it's done making significant use of unique MIT or MIT resources, which doesn't count almost anything in software, because the library doesn't count, your office doesn't count, your laptop doesn't count. But if you're in materials, biotechnology, and occasionally software, for example, it's a patentable algorithm that was developed under a grant to MIT, then MIT owns it. Which often is a good thing, because if you're part of the MIT community, sometimes when you would own it yourself, you may choose to let MIT own it, because first of all, they spend the money on the patents, and second of all, you have very clear title, and the TLO doesn't take that much of what might come out of it in licensing. Now, I have been in probably 25 or 30 different countries in which they want to set up a technology licensing office, and somehow the magic, your backyard will turn into Kendall Square in 5 years. And they say, well, what's the magic sauce? How did Kendall Square get developed? I'm not very popular when I say, we'll start with 50 years. Because communities evolve. And if you look at what's gone on at MIT, where companies have been spinning out for 60 or more years direct from MIT labs, including Bose Corp, by the way, which my husband was Amar's student and got all the data for that thing, but they didn't take licenses then. They just went out the nice wide back door. It actually was, and here's where we get into community building. It was a long-term, unofficial partnership between MIT and the community. It was MIT coming up with some fundamental technology and well-educated students, going out, forming new companies, or bringing technology out to the companies they went to work for, like IBM. But as new companies started to form, that in turn attracted venture capital. And if you go back when I started the TLO, almost 30 years ago, but let's go back 25 years ago, when we started a new company and we're looking for investors, we had to go to New York, or we had to go to California, to get the venture capital, because there was very little in Massachusetts. But as more of this started happening, not only did new venture funds form, but the old venture funds set up offices in Boston. So this kept going. Obviously, the price of real estate went up, and Kendall Square changed from the desert it was 30 years ago, well, certainly 50 years ago, to high-priced real estate now. And by the way, transportation became very important at that point. Without the red line, I don't think Kendall Square would be what it is. And by the way, what are you going to do about Seaport and getting the people there when it becomes the next Kendall Square? That's going to be a problem. The other thing that happened is that when you go around the world and you look at starting companies, you have to have transportation, you have to have reasonable permitting so that people can build things. Then you have to have money, angel capital and venture capital. And clearly money's hard to get there. But the scarcest resources of all when you are trying to build new companies is experienced CEOs who know how to manage science towards innovation and who know how to raise money for new companies. Now, the nasty little secret is that when you get clusters like you have here in biotechnology or IT, the clusters grow their own food. They grow their own CEOs. If you start a new biotech company in Kendall Square right now and you need a CEO, well, she was probably number 3 in the last biotech company that was formed. So it's a very interesting dynamic between a major research university and a community if the university knows that it can't control the process, it can only catalyze it. Thank you.
Thank you, Lita.